Welcome to Vision Plus and welcome to this Senior for Mathematics on Complex Numbers. Today we are on example 2 of division of complex numbers. And example 2 says, if z1 is -1 plus 2i, z2 is 3i plus 2, and z3 is 4i, find part A, z1 over z2. So the solution, part A, which is z1 divided by z2, would be, the first step is we start by substituting for z1 and z2. So here we shall say solution. So for part A, which is z1 out of z2, now we need to substitute for z1. What is z1? z1 is -1 plus 2i divided by z2. What is z2? z2 is simply 3i plus 2. Now, when we are dividing complex numbers, our aim is 1. We don't need I to be on the denominator. So we'll try as much as possible to make sure that there is no I on the denominator side. And if there are two terms on the denominator, as you have seen, our first step is always to get the conjugate of the denominator. So we shall just say here conjugate. And the conjugate is always strictly for the denominator. And we say that for you to get the conjugate of any complex number, what you just need to do is you change the sign of the term carrying I. In other words, we change the sign of the imaginary part, which is here 3i. This is positive 3i. Remember, we are focusing on the denominator to get the conjugate. So the conjugate of the denominator becomes -3i plus 2. Now, after getting the conjugate, we need to multiply both the numerator and the denominator by the conjugate of the denominator. That way, we shall be in position to remove I from the denominator without changing the meaning of the expression. So, therefore, we need to substitute. Here we have -1 plus 2i. Okay, let me say z1 out of z2 equals to -1 plus 2i out of 3i plus 2. Now let me multiply both the numerator. Since there are two terms, you put them in the bracket, times the conjugate of the denominator, which is -3i plus 2. Also on the denominator, you multiply the denominator by its conjugate, which is -3i plus 2. This way, we shall see that this I will cancel out, and we shall find that we have not changed the meaning, because simply this and this can be cancelled out. So we are getting the alternative expression to get rid of I. And then from here, the next step is simply multiplication. So here we shall have equals to, remember how we multiply. If you are not familiar with how we do multiplication of brackets, please go and watch our previous videos under multiplication of complex numbers. -1 times -3i to give us positive 3i. -1 again times positive 2 gives us here -2. 2i times -3i gives us -6i but squared. 2i times 2 gives us positive 4i. That is a multiplication on the numerator. But we are dividing it by the denominator, which is a product of the denominator and its conjugate. Still, because every term in one bracket has to multiply all the terms in other bracket. So we start with 3i times -3i. It gives us -9i squared. 3i times 2, it gives us positive 6i. Now we are done with 3, we come to 2. 2 times negative 3i, it gives us negative 6i. 2 times 2, it gives us 4. So on continuing, we shall say z1 out of z2 equals to, then we come and simplify by collecting the like terms. So I have 3i, and here I have 4i. So we'll say 3i plus 4i, then you have minus 2. I'll put there minus 2. Then I have minus 6i squared. So we'll say minus 6. But what is I squared? I squared is the same as negative 1. So Euler's property that I squared is negative 1. Then we put it here. I squared equals to negative 1. And then we are dividing it by negative 9i squared. Negative 9. But what is I squared? I squared is negative 1. 6i minus 6i. These ones are going to cancel out. It will give us 0. And then plus 4. So we could just go here plus 4. Because 0 makes no difference when we add it to those numbers. So here we are going to simplify. 3i plus 4i gives us 7i minus 2. Negative 6 times negative 1 becomes plus 6 over negative 9 times negative 1 is positive 9 plus 4. So on continuing here, it gives us 7i. Negative 2 plus 6 is positive 4 out of 13. Or alternatively, this is the same as 7i out of 13 plus 4 out of 13. Why? Because a denominator is distributed on condition that the terms in the numerator are being added or subtracted. And the order doesn't matter. Somebody could have 4 out of 13 plus 7i out of 13. So this is the answer for part A. And going to part B, it is not going to be of much difference. We shall follow the same procedure. What will change are just the values or the expressions of the different complex numbers. So part B is saying that we need to find Z2 out of Z3. So the first step is we substitute. What is Z2? Z2 is 3i plus 2, but we are dividing it by Z3. What is Z3? Z3 is 4i. This is the first step. What is our aim when we are dividing complex numbers? Our aim is that we don't need I to be on the denominator. So what we do is we find possible ways to get rid of the I on the denominator. How do we do that? We do that by getting the conjugate of the denominator, strictly conjugate of the denominator. What is the conjugate of 4i? Remember, when we're getting the conjugate, we simply need to change the sign before the imaginary part of the complex number. And as you can see, Z3 is 4i. It means the real part is 0. In other words, it does not have the real part. So this means we need to make it negative 4i. After getting the conjugate of the denominator, then we now say Z2 out of Z3 equals to, what is Z2? Still 3i plus 2 out of Z3, which is 4i. Remember, now we need to multiply both the numerator, which is this, times, we need to multiply it by the conjugate of the denominator, which is negative 4i. Still even, we also need to multiply the denominator by its conjugate, which is negative 4i. Then after this, now the next step is simply multiplication and simplification. So please make sure you are familiar with how to multiply two or more complex numbers. So we start 3i times negative 4i will give us negative 12i squared. Why? 3 times negative 4 is negative 12. I times I is I squared. And then since here we have only one term, 3 has multiplied it. Then we come to 2. 2 times negative 4. This gives us negative 8i. So here we shall have minus 8i. And we are done with the numerator. Divide by, also the denominator there is one term each bracket. 4i times negative 4i. 4 times negative 4 is negative 16. I times I is I squared. After that, we need to just simplify further since we have multiplied by the conjugate of the denominator. So going on, you shall have z2 out of z3 equals to, what do we do here? We substitute for I squared. You know I squared is negative 1. So here we shall have negative 12 times I squared, which is negative 1, and then minus 8i over negative 16. We substitute for I squared as negative 1. So we shall have here negative 16 into negative 1. Why? Because we know that I squared equals to negative 1 from Euler's property, which is the foundation of complex numbers. And then we further simplify this. Negative 4 times negative 1 is 12 minus 8i out of negative 16 times negative 1 is simply 16. As you can see that here on the denominator, we no longer have I. There is no imaginary part on the denominator, and that is our aim. Then we proceed. This is the answer. This answer is correct, but it's not in the simplest form. So we could just say this is the same as 12 out of 16 minus 8i out of 16. And then we simplify. By 4, we get 3. 16 divided by 4, we get 4 minus this one is independent. By 8, we get 1, which is the same as I. Out of 16 divided by 8, we get 2. And the order does not matter. Now, let me give you a quick NB. If the denominator is only imaginary part, then you could just simply multiply both the numerator and the denominator by that imaginary part of the denominator. That is quicker. And let's see, it will give us the same answer. This is alternative. If we go to have z2 out of z3 being equal to, here we have 3i plus 2 out of 4i. Since here there is no real part, we could just go on and multiply both the numerator and the denominator by the denominator, no longer its conjugate. Why? Because we only have the imaginary part, there is no real part. But if there is a real part, you must get the conjugate. So when multiplying this by 4i up here, also the denominator by 4i, we should be in position to get the same answers. This equals to 3i times 4i, that gives us 12i squared. 2 times 4i will give us 8i plus 8i over 4i times 4i is 16i squared. But remember, we shall say I squared equals to negative 1. So this now becomes 12 into negative 1 plus 8i out of 16 into negative 1. On further simplifying, we shall have here negative 12 plus 8i out of negative 16. Then we distribute the denominator. We shall have negative 12 out of negative 16 plus 8i out of negative 16. Negative and negative here will give us positive. By 4, we shall get 3. 16 divided by 4, we shall get 4. Here, since it is negative, positive divided by negative is negative here. By 8, 8 divided by 8 is 1, which is the same as 1i, which is the same as I. Out of 16 divided by 8 will give us 2. So you are seeing that that is also an alternative and is giving us the same answer. So only on condition that the denominator is an imaginary part, there is no real part, you simply go on and multiply the numerator and the denominator by the denominator. But if there are two terms, there is a real part and there is imaginary part, please make sure you first start by getting the conjugate of the denominator and then you proceed.